Item number 23. The enrollment at a public two-year college rose from 16,000 students in 2005 to 24,000 students in 2010. What was the percent of increase in the number of students over this 5-year period? Round to the nearest tenth if necessary. So the key to solving this problem is recognizing what bits of information are needed. To find the percent of increase, you have to have the amount of change, so how much it went up by, and you're going to divide that by the original amount. So it rose from 16,000, that is our original amount, to 24,000. Now we have to find the amount of change, so to find the change, take the 24,000, subtract the 16,000, and that's going to give us 8,000. So it went up by 8,000. And if you reduce this, you get 1/2. And of course, 1/2 is 0.5 or 50%. So the enrollment had a 50% increase over the 5-year period. Now, you really don't need the 5-year period. You don't need these years. You don't need that number 2. You just have to be careful and make sure you're using just the information you need to find the percent of increase. Number 24. Use dimensional analysis to convert the quantity to the indicated units. If necessary, round the answer to 2 decimal places. 84 inches to feet. 84 inches. Dimensional analysis means we need to multiply by a unit fraction. Our unit fraction will need to have inches in the denominator, feet in the numerator, because that's what we want to change to, from inches to feet. These inch units are going to be gone. There are 12 inches in 1 foot. We end up with 84 over 12 feet. Divide 12 into 84, it goes 7 times, so the answer is 7 feet. Number 25. Use dimensional analysis to convert the quantity to the indicated units. If necessary, round the answer to 2 decimal places. 30 feet to yards. We want our final answer to be in yards, so yards will be the unit in the numerator. Feet will be the units in the denominator of our unit fraction. There are 3 feet in every 1 yard. Our feet units will be reduced out. We'll have 30 over 3 yards. That's 10 yards. Use dimensional analysis to convert the units indicated. 345 kilometers to miles. 345 kilometers. I'm going to have kilometers in the denominator and miles in the numerator because we want our final answer to end up in the miles unit. This is a case where you need to know how many miles are in a kilometer or how many kilometers are in a mile. You need to know the relationship between these. and there are 1.6 kilometers in every 1 mile. So we're going to end up with 345 in the numerator and 1.6 in the denominator. So you can take your calculator and divide that. 345 divided by 1.6, and you get 215.625. And we're asked to select from those answers that are here. So answer D, this is approximately 215.6 miles. And be sure to include your units in your answer. Item number 27. How much money should be deposited today in an account that earns 5% compounded quarterly so that it will accumulate to $6,300 in 2 years? We want to know the amount in the account today. That's a present value. So we will use the following formula to answer this question. In our problem, we know that the amount we want in the future is $6,300. We know that our time is 2 years. We've got an annual interest rate of 5%, and we know that it's compounded quarterly, which is 4 times per year. To find the amount that we need to deposit today, we take our $6,300, that's our future value. We divide that by 1 plus 0.05 is our rate, 4 times per year. Here's where you have to be really careful. You've got to multiply n times t in your exponent. So my recommendation is always to go ahead and multiply out that exponent, because if you forget to put parentheses around that exponent, you're going to miss it in your calculator. And we can now divide this on the calculator and just enter it just like it is. So we can say 6,300 divided by parentheses 1 plus 0.05 divided by 4 raised to the 8th power, or if you do 4 times 2, you have to put the 4 times 2 in parentheses. We get, for our answer, $5,704 and a penny. $5,704 and 1 cent. That is the amount to be deposited today to grow to $6,300 in 2 years. Item number 28. James and Janice are planning on putting away money for their new daughter's college education. In order to have $50,000 available for her college in 18 years, how much should they deposit each year in an account earning 3% annual interest compounded annually? So, we know the following. Future value is $50,000. They want to have $50,000 in this account. The time is 18 years. The rate is 3%. It's compounded one time per year. So the formula we will use and the formula looks like this. The amount you would like to have times the rate divided by the number of compounding periods divided by, in brackets, parentheses 1 plus r over n to the nt, subtract 1, close your brackets. So we'll put in the amounts that we know. 50,000. Our rate is 0.3. Now our n happens to be 1, so you really don't have to write the 1, but I think it's good practice just to do this, because maybe you're going to make deposits more than once per year and you're going to have to enter that n number. So this would be 0.03 over 1 to the n times t. Remember to put this in parentheses. If it was anything other than 1, you really would have to be careful about that. 1 times 18, subtract 1. Now I'm going to clean this up a little bit, and I recommend that you do the same. Just remember that in order to not get rounding errors, carry your calculations in your calculator as many decimal places as you can see on the screen. There should be a -1 here. And so we've got to be really careful. In order of operations, you need to do this numerator first. I'm going to go ahead and simplify it a little bit, because I will tell you that the most common mistake that is made when doing these kinds of problems is simplification. You write everything for the formula down correctly, and then you enter it in the calculator wrong. So I've got 1,500 here, and I'm going to get my decimal for my denominator, and I'm going to carry it as many places as my calculator shows. That's going to be 1.03 to the 18th. Subtract 1. It will do that in the right order for us. 0.7024330,612. So I'm going to write that down. 0.7024330,612. I want to verify that I have that right. 7024330,612. All right, and so I'm going to finish it up by taking my 1,500 and divide that by 0.7024330,612. And I'm going to get 2,135 and 43 cents. So that's choice A. 2,135 and 43 cents. So you have to be really careful when you enter this in the calculator. If you're not sure, it's always safest to put parentheses around your numerator and brackets or parentheses around your denominator to be sure, or Go ahead and simplify the entire numerator, simplify the entire denominator, carry your decimal points as many places as the calculator shows, and then you'll get your answer correct to the nearest penny. Item number 29. How much money will be in the account after the given number of years, and how much interest was earned in that period if $8,000 is invested at 4% interest compounded quarterly for 5 years? So we know that the amount invested is $8,000. We know that the rate it's invested at is an annual rate of 4%, changed to a decimal. We know the time is 5 years, and we know that it is compounded 4 times per year. So we're going to use a formula for compound interest, and that is that the amount in the account will be the principal times 1 plus R over N to the NT. So we fill in our formula, 8,000, 1 plus 4%, 4 times a year. Here's the part where you have to be careful. 4 times 5 needs to be in parentheses. Now, if you've got it written like this, you can work this out in the calculator, just type it in just like this. Or if you want to be safe, do what you know about order of operations. You're going to do in the parentheses. And then you're going to do exponent and then multiply. Or we can just take out our calculator here at this point and say we're going to take 8,000 times, I'm going to put it in parentheses. It doesn't have to be, but if you're not sure, it's always safest to do that. Raised to the 20th power. And it gives us our answer of $9,761.52. So $9,761.52. And then you can see that's here. But let's talk about how you get this interest earned, even though you can tell already that the choice is A. You would take your $9,761.52. You'd subtract your original investment of $8,000. That's where you get $1,761.52 as the interest that is earned on that money, that $8,000 invested for 5 years, compounded quarterly at 4% annual interest rate. Item number 30. The price of a home is $430,000. The bank requires a 20% down payment. The loan will be a 25-year fixed-rate mortgage at 6.5% or 6.5%. Find the A, down payment, and B, the monthly payment. The total for the house is $430,000. Down payment 20%. So the first thing we need to do is multiply by 20%. We do that, we'll get $86,000. So the amount that we're going to borrow is going to be the $430,000. Subtract 86,000, and that gives us our p-value in our loan of $344,000. Now we also know that the rate as a decimal is 0.065. The time is 25 years. And it's compounded monthly because you have monthly payments, so your N has to be 12. So the formula for the payment is the amount you borrow times R divided by N divided by 1 minus 1 plus R over N to the negative NT. So 344,000 0.065 over 12. That's what's going to go in our numerator. All that's going to be divided by 1 minus 1 plus 0.065 divided by 12 to the negative, and in parentheses, 25 times 12. Now this is one of those where I definitely recommend that you clean it up a little bit before you try to enter it in the calculator. So I'm going to get my numerator first. That's 344,000 times 0.065 divided by 12. So in the numerator, 1863.3333 repeated, and you do want to write out about 8 of those 3's. Make sure you don't have a rounding error. It's not as big a deal in multiple choice, but as you know with the online exercises, you have to be really careful. In my denominator, there should be a bracket here. I'm going to multiply out this exponent and put it in parentheses. See, in my denominator, I'm just going to enter it as I see it here because I've got parentheses around the exponent. You could do what's in these parentheses, go about 8 decimal places, multiply this out, and go from there. But as long as we have parentheses around our exponent and we go from left to right very carefully, it will do this in the right order for us. So I'm going to go over here where I can see. I'm going to type in 1 minus parentheses 1 plus 0.065 divided by 12, close parentheses, raised to, parentheses, negative 25 times 12. Now if you forget those parentheses, you're going to miss this. So anytime you have an operation in an exponent, you want to be sure you put those parentheses around that. So the value that I got there needs to go in my denominator, 0.802222929. 0.802222929. So carry it out as many decimal places as you see on the screen. And so now I'll just divide 1863.3333333 divided by 0.802222929. Now I left out one of the 2's in there, but there are 4 2's here. So I'm going to write that in there. 232269. Should be another 2 here. 232269. 69. Now you can see that I got a little bit of a rounding error because I did the rounding, but that's the closest answer. I'm thinking maybe I made a mistake there. I'm just going to do this one over. So item number 30. The price of a home is $430,000. The bank requires a 20% down payment. The loan is a 25-year fixed-rate mortgage at 6.5%. Find A, the required down payment, and B, the monthly payment. So let's first write down what we know. The house is $430,000. Our down payment has to be 20%. So we can calculate that by multiplying 20% times 430,000. The time is 25 years. The rate is 6.5, so 0.065. And it is a monthly payment. That means it's going to be compounded 12 times a year. The first thing we need to do is find that down payment. So multiply this times 0.20. We'll get $86,000, which means the loan amount, which is going to end up being our P in our formula, is going to be $430,000. Subtract $86,000. So our loan amount is going to be $344,000. So now we have everything we need in order to find the payment. We'll use the payment formula, which says, take the amount of the loan, multiply that by the rate over the number of times the money is compounded in a year, number of payments, the same as the number of payments. Divide that by, so let's write this formula down. So our formula we're going to use is the payment formula, and that's going to be the amount borrowed times R divided by N. Once you get that, you'll divide it by 1 minus 1 plus R over N to the negative N times T. So we have all of the values we need in order to do this. We've got 344,000. We've got 0.065 divided by 12. And in our denominator, we've got 1 minus 1 plus 0.065 divided by 12, all raised to the negative nt. And what I'm going to do is I'm going to go ahead and multiply 12 times 25 and get that value for my exponent here so that I don't make a mistake when I enter this, because if I forget to put parentheses around that exponent, I'm going to miss this even if I get everything else right. So we've got 300 payments total, and so right here I'm going to put negative 300, close parentheses. Now I can enter this in the calculator just as I see it, and I will get the correct answer. So in the numerator, and if you're unsure, it never hurts to put parentheses around your numerator. Turns out you don't have to have them in this case, but it never hurts to do that. 344,000 parentheses 0.065 divided by 12. All that's going to be divided by, and you've got to put parentheses or bracket, you can just put another set of parentheses. Left paren, 1 minus another paren, 1 plus 0.065 divided by 12, close the parentheses, raised to the negative 300, and if I had not multiplied that out, I'd have to put parentheses around the negative 12 times 25. Now I'm going to close my parentheses. All right, I've got 2 parentheses here and 2 parentheses here, and I get 2,322.71 cents. 2,322.71 cents. So you can see that that is part C. Now, if you want to multiply out the numerator and get a value, and go ahead and get a value for the denominator, just go, enough decimal places, and because it's multiple choice, you'll be able to find the one that's closest. But often, if you don't do it exactly as you see it here, you won't get it right. You'll miss it by a penny or so. But generally speaking, if you carry 8 or 9 decimal places, you should be fine. So the answer to this one is $2,322.71. Item number 31. Use the Pythagorean theorem to find the missing length in the right triangle. Use a calculator to find square roots, rounding if necessary to the nearest tenth. So if we need a calculator, we will use it. Now, the Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse of a right triangle. So 6 squared plus b squared equals 10 squared. So that's 36 plus b squared equals 100. Subtract 36 from both sides to get b squared equals 64. Now, there are actually 2 numbers you can square to get 64. You can go negative 8 squared, because negative times negative is going to be 64, and positive 8 squared is going to also give me 64. But because this is the length of the leg of a triangle, it doesn't make sense to have a negative length. So the answer is just b equals 8. Pay attention to the units, 8 kilometers. So our answer is answer A. Item number 32. Find the perimeter of the figure. Well, the figure is a rectangle. So the perimeter of a rectangle is 2 times the length plus 2 times the width. And with any figure, if you want to find the perimeter, you can add the lengths of all the sides. So since this is a rectangle, the opposite sides will have the same length. And we're assuming it's a rectangle. We don't know for sure that these are right angles. It could be a parallelogram, but the opposite sides are going to have the same length. And the perimeter will be twice the length and twice the width. So 2 times 10 plus 2 times 8, which would give you the same as 10 plus 10 plus 8 plus 8. 20 added to 16 is 36. And perimeter is measured in linear units, so our answer is 36 feet. Item number 33. Solve the problem by applying the fundamental counting principle. Now, the fundamental counting principle basically says if you have one item that you can choose n ways, another item that you can choose m ways, and even another item that you can choose p ways, that you just multiply those ways together. So, in addition to coffee, a local coffee shop also sells ice cream. The shop offers 5 flavors of ice cream, along with 2 types of cones and 6 choices of toppings. If you are to build a treat by selecting 1 flavor, 1 type of cone, and 1 topping, how many different ways can you build your selection? So this is the fundamental counting principle. We have 5 flavors, we have 2 kinds of cones, and we have 6 kinds of toppings. If we multiply that together, we get 10 times 6 is 60. So there are 60 different ways that you could build your ice cream cone. Item number 34. There are 124 people running in a local 5K race in the 60 to 69 age range. The first, second, and third place runners to cross the finish line will win a trophy. If you were to calculate the total number of ways the winners could cross the finish line from among these 124 runners, would you need to use a combination or a permutation, and why? Well, the key to this problem is that there's a first, second, and third place. So it does matter what order these runners come in when they cross the finish line. So the answer is going to be C, a permutation, because the order of letters and numbers will matter, and in this case it's the number of racers you have in a certain age range. So since it will matter, it's going to be a permutation. Item number 35. A club elects a president, vice president, and secretary-treasurer. How many sets of officers are possible if there are 10 members and any member can be elected to each position? No person can hold more than 1 office. So once again, you ask yourself, does the order that these folks are selected matter? So is the president different from a vice president? Is that different from a secretary-treasurer? Since it is, you're going to do a permutation of 10 items or 10 people selecting 3. Now there's a factorial formula for this, but it will reduce down to 10 times 9 times 8. And you always, this is sort of a shortcut that I use, start with this number and count down this many factors, counting down by 1, because can't be the president and the secretary. So you've got 1 less person to choose for the second office, and that turns out to be 720 choices. Number 36. From 8 names on a ballot, a committee of 3 will be elected to attend a political national convention. How many different committees are possible? Now, in this case, unlike the last item, the order will not matter because the 3 committee members are serving in the same capacity. That makes this a combination of 8 choose 3. Once again, there is a factorial formula for this, but there's a little shortcut. Start with 8, count down, 8, 7, 6, and then in the bottom start with 3, count down, 2 times 1. This is, if you use the formula, this is what the formula will reduce down to. You can do a little bit of simplification there, and we end up with 56 ways the committee could be formed. The committee of 3 could be formed. Item number 37. Use the theoretical probability formula to solve the problem. Express the probability as a fraction reduced to lowest terms. A die is rolled. The set of equally likely outcomes is 1, 2, 3, 4, 5, 6. Find the possibility of getting a 3. So you have to know the total number of possibilities. You have to know how many outcomes there are for your specific outcome, which is just 1, because there's only 1 3 possible out of 6, so the probability that you will get a 3 is 1 out of 6. Item number 38. Find the mean for the group of items. To find the mean, you add the items together. 9 plus 2 plus 3 plus 8 plus 5 plus 11 plus 4 plus 3. Then you divide by the number of items, 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8 is 5.625, and when you look at your choices, the closest one is 5.63. So the correct answer is C, 5.63. So add the items together, divide by the number of items to get the mean, and of course mean is the same as finding the average. Find the median for the group of items 10, 6, 4, 0, 1, 1, 1, 0, 0. In order to find the median, you need to list your values from smallest to largest, or you could do largest to smallest. And I always mark them out as I write them down, just to be sure that I've got them all. 4, 6, and 10. So the median is the number that is in the middle of these. So I'm going to count my items. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since they're an odd number, there's going to be the exact number below and the exact number above. And so there is going to be the median exactly in the middle. So the median here is 1. Now, if we had only had 8 items, let's just get rid of that 10 on the end there. Pretend that the 10 was not in the original set. So you have 8 items. You'd have to find the average of these 2 items, which happens to also be 1, but these numbers may not be the same. So you have to add them together and divide by 2 if you don't have an odd number of items. Don't have a distinct median. You have to divide the 2 numbers that are in the middle together to find the number that's halfway in the middle of those, because you want the same number above as the same number below. Item number 40. Use similar triangles and the fact that corresponding sides are proportional to find the length of the side marked with an X. So the first thing you probably should do is orient the triangles, kind of redraw them so that they're facing in the same direction so that you get the right sides in your proportions. So I have an X and a 7. I have a 48 long side and a 24 long side. I have a 50 hypotenuse and I have a 25 hypotenuse. And I'm asked to find the side that's marked X. Now, this is a right triangle, and you could use Pythagorean theorem if this is in fact a right triangle. But we don't want to do that because it's easier actually with these numbers to just go ahead and use ratio and proportions. So X is to 7. This short vertical side is to this vertical side 7. As you can go 50 over 25 or 48 over 24. I'll just go with the 50 over the 25. So X over 7, make the multiplication easier. Reduce this to 2 over 1. Cross multiply, 1x equals 14. So the value of X, or the length of this side, is actually 14 meters. Item number 41. Find the mean and the standard deviation for the data set and round to 2 decimal places. So I'm going to do this on the calculator, even though we could do it by hand, and we'll talk about how to do it by hand. And I'm going to do this by entering in my lists these values. So if I clear my list, be careful, don't hit delete, hit clear. I can enter my items: 84, 54, 89, 69, 74. So to find the mean, we would add these up and divide, or using our built-in stat feature, stat, calculate, one variable statistics number 1. X bar is our mean, so our mean is 74, and our standard deviation is 13.69. This S sub x is the standard deviation when you do it this way. So answer C is the correct answer. Let's look at it manually. To find the mean, we would say 84 plus 54 plus 89 plus 69 plus 74, all divided by 1, 2, 3, 4, 5. So we would do the sum of these numbers, 84 plus 54 plus 89 plus, this is 69, I wrote it wrong, but 69 plus 74 divided by 5, and there's my mean of 74. So you definitely can easily find the mean of 74, and so you'll see that it's here. But let's talk about how you manually can find the standard deviation. So if we want to find our standard deviation manually, the first thing we do is we take each data item and we subtract the mean from it, so that we can figure out how each individual item differs from the mean. So I've got to subtract 74 from each one of these to find what's called the deviations. How does it differ from the mean? And we'll know if we've got our deviations right if they add up to 0. So we've got a 10. 54 minus 74 is a negative 20. 89 minus 74 is positive 15. 69 minus 74 is negative 5. 74 minus 74 is 0. If we were to add these up, we've got a 10 and a 15, that's a 25. We've got a negative 20 and a negative 5, that's a negative 25. So those deviations add up to 0, and that makes me know that that part is correct. Now we want to square each one of these, because just adding them together gives us that 0. It's not helpful. So we have 100, and we have 400. When you square, everything's going to be positive. 10 times 10, negative 20 times negative 20. 15 times 15, I'm going to pull out the calculator for that one. I think it's 275 or 225. 225, yeah. So that's 225. And then negative 5 squared is 25. And then, of course, 0 squared is 0. Going to add these together. That's 500 and 250. So that's 750. That's the squares. So remember, for the standard deviation, we're going to take each item, subtract the mean from it. We're going to square that. We're going to divide it by n minus 1, and then take the square root of that. So we're going to take our 750, and instead of dividing by 5, we're going to divide by 4. And that's going to give me 750 divided by 4. 750 divided by 4 is 187.5. And then we want to take the square root of that. 187.5, square root of that is 13.69, which is what we got here. So the square root of this guy is approximately 13.69. 15.69. So remember, we're dividing by n minus 1 and not n when we do our standard deviation. Items 42 and 43. Use the scatter plot shown to answer the questions. Which scatter plots indicate some positive correlation? So in order to have a positive correlation, the points need to approximately lie on a straight line with a positive slope. So notice you can see a line here, you can see a positive slope here, and you can see a positive slope here. Now that one's negative, so that's not going to be an answer. That one's negative, and this one is not really correlated. They're just, the points are just everywhere. So our answer for the first one is B, C, and D. And some negative correlation would be those points that lie on approximately on a straight line with a negative slope. So you can see a line there, and you can see a line there, and here again you can't see any correlation here. So that's going to be the answers A and F for part B. So item number 44. Use the table above to calculate the tax owed by the person described below. A head of household person with $41,000 in taxable income, 2 dependents, deductions of $3,200 for state taxes, $1,000 for mortgage interest, and no tax credits. So head of household means we're going to be looking at the last column. The standard deduction is $8,000. This person has $4,200 in deductions, so definitely going to take the standard deduction and not itemize. We've got to take our $41,000, subtract that standard deduction. That's going to get the income down to $33,000. Then the person gets 3 exemptions because there's 2 dependents plus the person who's the head of household. So that's 3 exemptions. So that's $3,500 times 3 is $10,500. So we're going to subtract from this another $10,500, giving the person an adjusted gross income on which taxes will be paid of $22,500. All right, so now we have to calculate that tax on that $22,500. The first amount up to $11,450 is at 10%. And then we're going to have to pay on the other amount $11,050. They're going to have to pay 15%. So we have to do $11,450 times 10% plus what's left over here, $11,050 times 15%, 0.15, to get the tax that the person owes. So that's $11,450 and 10% multiplied plus $11,050 times 15% is $2,802.50. And this answer is marked incorrectly here. The actual answer is $2,802.50.